This is video number 4 in our exponent series. The topic is dividing exponents. So finally we want to look at what happens when exponents are divided. So I might have, for example, 7 to the 9th divided by 7 to the 4th. We write division like that, like a fraction. And the easiest way to decide what the answer is going to be is to expand it out and show what it looks like. So 7 to the 9th would look like 7 times 7 times 7. 7 times itself 9 times. And that would be on the numerator part of the fraction, or on top. And on the bottom we'd have 4 7s as factors. 7 times 7 times 7 times 7. Now an interesting thing here is a side note, is that anytime you have a number over itself, that's just what we call a fancy form of 1, or a 1. So for example, if I do a little bubble up here, if I have 5 over itself 5, that equals 1. If I have 12 over 12, that's also 1. Anything over itself is 1. So I keep that in mind as I'm looking at this expanded form of 7 to the 9th over 7 to the 4th. Because what I can do is I can look here and I see a 7 on top and a 7 on bottom, and I can divide those two 7s and get a 1. So I cross them out. Now there's actually a 1 there, but I don't really need to keep it, because 1 times anything is that thing, so I don't really need to write anything times 1. So I look for 1s. Here's another 1, here's another 1, and here's another 1. And so what we did is we divided by 1 several times here. Then we look at what we have left. And on the numerator of my fraction, I have 1, 2, 3, 4, 5 7s. So I have 7 to the 5th power. In the denominator, it doesn't look like I have anything, but I actually have a 1. So it'd be 7 to the 5th over 1. Now I don't really need that 1, because we also know that when I divide by 1, a number stays the same too. So I could write it as 7 to the 5th over 1, or I can just write it a little bit simpler as 7 to the 5th power. Now I can do the same thing with variables. If I had b to the 6th over b to the 3rd, that would look like a bunch of b's, 6 of them, on top, and 3 of them on the bottom, all multiplied together. So the top would be b to the 6th, bottom would be b to the 3rd. And then I can look for 1s, and a b divided by b is a 1, a b divided by b is a 1, and there's another 1. So again, I'm left with b to the 3rd over 1, or just b to the 3rd. So again, we want to develop a general rule for dividing exponents. So that I have a base of a to the m power, and I divide that by the same base to a different power. What we find is that the answer will always be the same base, but instead of adding or multiplying the exponents, if I subtract them, I get the answer. So if you remember back, we did 7 to the 9th over 7 to the 4th, and our answer was 7 to the 5th power. I can get that by 7 to the 9 minus 4 power, or 7 to the 5th power. And that's a little bit faster than expanding it out, although expanding it out helps you understand why. So the same is true if I have b to the 6th over b to the 3rd. We end up with b to the 6 minus 3, or b to the 3rd power. Now one final note about division. Sometimes we will have situations like this: m to the 3rd over m to the 4th. And this time there are less m's on the top than on the bottom. In other words, the numerator has less factors than the denominator. So if we wrote out what this looks like, it looks like m times m times m on top, and m times m times m times another m on the bottom. If we look for 1s again, we can cross out m divided by m, and another one, and another one, and this time on the top we don't have anything, so we would write 1 on top, because we actually have a 1 up there, and then on the bottom we have 1m left over, or m to the first power. Now if we apply our rule to this, it would be m to the 3 minus 4 power, or m to the negative first power. And so we can have negative exponents as well. Notice that they're not a negative amount, they're just a small exponent. So we also see a pattern here that m to the negative first is what we get with the rule, but we can write that as 1 over m to the positive first. Now, sometimes we put some of these rules together with division. For example, if I have 8n to the 4th over 10n to the 6th, the best way to understand this, I think, is to factor this out a little bit and say the top is going to be 8 times n to the 4th, and the bottom is going to be 10 times n to the 6th. That way we can look at this part right here, this 8 over 10, which is really a fraction. It's 8 divided by 10, but it's also 8 parts of 10. And what I can do with that is I can simplify 8/10. I know that there's a factor of 2 in each of those, so I can divide 8 by 2 and get 4, and I can divide 10 by 2 and get 5. And I'm going to go ahead and extend my fraction bar a little bit, because now I've got to deal with my n's. And on the top I have 4 n's, and on the bottom I have 6 n's. So if I use my rule for this part of it, this would be n to the 4 minus 6th, or n to the negative second power. And since I prefer not having a negative exponent, what I'll do is I'll switch that to the bottom and write n to the positive second power on the bottom of my fraction. But it would be a different way to write it as 4/5 n to the negative second power. It's just that we tend to prefer a positive exponent. Another way to understand that last problem and understand the y behind it, if I write 8 times n to the 4th over 10 times n to the 6th, and I break it down into what we call prime factors, so the very smallest factors possible. 8 can be written as 2 times 2 times 2. All those numbers are prime. And then the n to the 4th part can be written as n times n times n times n. So I've chunked this numerator up into the smallest pieces possible. Now if I do the same thing on the bottom, I get a 2 times 5 makes 10, and then I've got n to the 6th, so I've got 6 n's all multiplied together. And then what I want to do is I want to look for 1s. So I find a 2 divided by 2 right there is a 1. And I find an n divided by n is 1. Here's another 1, another 1, and another 1. So then if I were to look at what's left on my numerator and my denominator, on the numerator I've got a 2 and a 2. And 2 times 2 makes 4. On the denominator I've got a 5. And I've got that times by 2 n's, or n to the second power. So that's why the answer on the previous screen was 4 over 5 n to the second power. And that concludes video number 4, dividing exponents.